Hello friends, welcome to the Mind Tricks. So in this lecture we are going to learn about the NAT gateway. So we'll learn how to create a NAT gateway, how that can be attached to the private subnet, and using the NAT gateway how we can access the internet on the EC2 instances available on the private subnet. So before we start, let us understand what is the NAT gateway and why it is required to use the NAT gateway. Okay, so NAT gateway is NAT provided by the AWS, and when I say NAT, it means the network access transition. So when we use the NAT, actually there is a lot of the IP transitions happening. So that is why the NAT is required, and that is what the actually the NAT means. So the AWS provided NAT gateway has a higher bandwidth, higher availability, and almost no administration required for that. Whereas if we are using our own NAT instances, so for that the bandwidth and availability, those are dependent on the EC2 instances, what we are using, the size and type of the EC2 instances, and also the availability zone where we are using and where our the the VPC and the subnets have been created. Also, if I'm using the NAT instance, so in that scenario I'll have to create the security group and I'll have to manage all the stuffs like patching and updating the softwares for the NAT and all. Okay, so if I'm using the AWS provided NAT gateway, so almost no administration required, and the pricing is also for the per hour and also for the bandwidth. So for the NAT gateways, the minimum bandwidth which is provided by the AWS is a 5 Gbps, and it can auto scale up to the 45 Gbps. And obviously if it is getting auto scaled to 45 Gbps, then your pricing is also going to vary accordingly. And the last point, like I already mentioned, we should not, we don't need the security groups when you are using the NAT gateways. Now coming to the next point, so the NAT gateway uses the elastic IP, and why it uses the elastic IP that we are going to see after some time. But yeah, elastic IP is required when we are creating the NAT gateway. Another thing is that we cannot access the EC2 instances which is present in the same subnet as of the NAT gateway. Suppose I have a subnet called a public subnet, and if I'm creating a NAT gateway in the same subnet, so the EC2 instances available in the same subnet cannot access that particular NAT gateway. And obviously, NAT gateway standalone cannot provide the internet, so we require the internet gateway as well along with the NAT gateway to have internet access on the private subnets. Okay, so now let us see like why we need the NAT gateway. Okay, what is the requirement? So suppose we have a VPC and we have an internet gateway attached to this particular VPC. Okay, and within this VPC we have a public subnet and a private subnet, and within this private subnet you can see we have an EC2 instance. Okay, and to access this EC2 instance within the private subnet, what we did, we created a bastion host, and using this bastion host I can actually SSH to the security, the instance, the EC2 instance what I have in the private subnet. Okay, and the user can then indirectly, the user will be able to SSH the private subnet instance. So user will SSH to the bastion host, and from there we can SSH the uh, private subnet EC2 instance. And for a single bastion host is enough for like multiple EC2 instances in the private subnet. Okay, but here you can see we can only SSH to this private subnet instances. If you will try to ping this particular instance, you will not be able to ping it. Okay, so for that we actually need the NAT gateway to be created in the public subnet. And once we have the NAT gateway available in the public subnet, we can have a HTTP and HTTPS protocols also available on the private subnet. Okay, now let us see how that works. So we have a region, and within that region, suppose we have an availability zone. Okay, and within this availability zone we have created a VPC having a private subnet and the public subnet. Okay, and after that you can see we have created an instance in the private subnet. This EC2 instance we have created in the private subnet with the security group, and also we have a EC2 instance within this particular public subnet along with its related security group. Okay, now I'll have a route tables associated with each of the subnets, like the private table, the private subnet will have its own route table and the public subnet will have its own route table. As I mean, this is the general architecture what we have, and then we'll have a router and the internet gateway attached to the VPC. So if someone is trying to access something over the internet from the public subnet, it is easy, like the request will go to the internet gateway, and internet gateway will transfer it to the router, from where it will check the route table configuration and send the request to the public subnet EC2 instances, and it will get the responses accordingly. But what for the private subnet? What for the private subnet EC2 instance? We don't have anything yet, right? So for that, what we'll do, we'll create a NAT gateway over here, okay, and we'll update the private subnet route table accordingly. So if someone is trying to access something over the internet, like I'm trying to ping the google.com from the EC2 instance, so it will check in the route table, like what should I do with this request. It will say like route this traffic to the NAT gateway, and then NAT gateway will again connect to the router and internet gateway, and it will give the response accordingly. So this is how the NAT gateway should be configured, and it should be used. And let us see like how we can make it highly available. So suppose within our VPC we are having two availability zones, which is a general and a suggested scenarios. So suppose like if someday any one of the availability zone goes down, we'll still have our application running and it will not be affected, right? Sorry. So suppose we have an internet gateway attached to this particular VPC, and after that what we are doing, we have a router, and then we have a NAT gateway in both of the public subnets, correct? And then if someone is trying to access anything from a private subnet, even though if one of the availability zone goes down, we'll be able to access uh, uh, something from the NAT gateway which is available in the this availability zone. Okay, so now let us quickly jump into the our AWS and let us see how it can be done. So here if you'll see, I already have my custom VPC created, and it has a CIDR from 10.0.0.0/16. Okay, and if you don't know about CIDR, I'll create a separate video on that and how to create a VPC and subnets and uh, put it on the properly on the route tables. If you want, I can create a separate video on that as well. Okay, so for this particular VPC, I have created actually four subnets, two public subnets. You can see public subnet A and public subnet B. So the A one is available on the US East 1A, and the public subnet B is available on the US East 1B. And similarly, I have two for the private subnet as well, A and B, available on the two different availability zones. Okay, and other than this, I have a internet gateway created here. You can see I have a demo ICW created over here, which I have attached to my custom VPC. If you can see VPC ID, it says my VPC, which is my custom VPC. Okay, now let us go to the route table and check the public route table configuration. So here if you'll see the subnet associations, so I have already associated in the explicit subnet association, you can see I have associated both of my public subnets over here. And if you'll go to the routes of it, so here what I'm doing, this is the local, the CIDR destination, and it is routed to the local. And if you'll see for anywhere else, it is going to the internet gateway. Okay, and now let us check for the private subnet. the private route table. So if we'll go to the subnet associations over here, so in the explicit subnet association, you can see I have associated both of my private subnets over here. And if we'll go to the routes, so here you can see I have only the my cider block available here, and it is routing it to the local. There is nothing else. Okay, so what I'm going to do next now, I'll go to the NAT gateways. Okay, and I'll create a NAT gateway over here. So I'll click on that NAT gateway, and the name I'll put it as demo NAT GW, and I'll obviously put it on a public subnet. Okay, connectivity type will be public because we are using it to uh, connect with the private instances, and we need it for the internet connectivity and all. So that is why we'll go with the public connectivity type. And then this NAT gateway, it requires the elastic IP. So I already have a elastic IP created, so I'm going to use the same. So I have selected the NAT IP, and if you don't have that one, you can obviously go here and create a elastic IP for you. Okay, I'll click on the create NAT gateway. So it will take some time. So meanwhile, what we'll do, we'll go to our EC2, and we'll launch a instance over here. Okay, so I'm going to launch two instances over here. Okay, one I'll launch in the public subnet, and that will be as a bastion host, so I'll mention the same thing here. Okay, and this one I'll keep all the things as default, and T2 micro key pair login, I'll select the one I have. I selected this one. Okay, and in the network setting, I'll edit it. I'll choose the my VPC, my custom VPC, and this is going to be in the public subnet. And obviously I need the public IP to connect to this, to SSH to this particular instance. I already have a security group created for the bastion host, so what I'm going to do, I'm going to select that particular one. Okay, so it is nothing but this is just enabling the SSH from anywhere. Okay, that's all. So I'll go and click on the launch instance, and then I'm going to launch another instance which will be in the private subnet. Okay, so I'll name it as app srv private. Okay, the AMIs will be the default one, instance type will be T2 micro, and then I'm going to select this one. I'm selecting this one because I have a PIM file for this particular instance only. I don't have it for the other one. Okay, so if you have the PIM file for the same key pair, you can use the same key pair. Okay, so again I'm going to change it to my custom VPC, the my VPC, and it should be the private subnet. So I'll launch it in private subnet B. I don't need a public IP for this scenario, so I'm not going to enable it. And then I have a security group already created, so you can see it's a private Linux SG. So this does not have HTTP enabled. Okay, that's all. Rest thing will be the default one. I'll click on launch instance. Okay, so my bastion host is up. So let me go and copy this public IP, and let me connect it using the putty. Okay, and I'll select the key from here. So this is the key I'm using, and the default username will be EC2 user, and I have connected to my bastion host from here. Okay, so if I'll do ls, I don't have anything available here. It's completely empty, and so what I need to do, actually I need to connect to my private subnet from here. So for that I need the key pair, the PIM file. So what I'm going to do, I'm just going to create a file from here, and I have that file in my local, so I'm just going to use that only. Okay, so that should be here. Yep. Okay, so this is my file. I'll copy this stuff. Okay, and here I'm going to create that Linux. Let me check the file name. So this is Linux under Linux kp underscore vpc. Linux kp underscore vpc dot pem. I'll press I to go into the insert mode, and I'll paste that what I have copied, and press escape to come out of the insert mode, colon, right, quit, exclamation, and enter. So if we'll check the file now, so I have this file available, but it has a lot of access, read write access. Okay, so if I'm going to use this file with this access, the AWS is going to deny that because it has lot of access. So what I'll do, I'll change the access to the read only. So for that I'll do change mode 0400, and I'll put the file name, uh, sorry, the typo. Okay, and if I'll do the ls-lrt, you can see now it's a read mode only. Okay, now let us check our EC2 instance is up or not. So yeah, it is up and running. So I'll select this one, and I need the private IP address for my private instance. I'll go back to my putty. Here I need to do SSH uh, EC2 user, which is the default username, at the rate. I'll paste the IP here, -i, and then the uh, key pair file name. Okay, and I'll press enter. So it will ask me if you want to continue. I'll type yes, press enter. So you can see I got connected to this particular server, the app server. And if I'm trying to ping the google.com from here now, it will not work. I'll not get any responses. Okay, but if I'll come out of this one, I'll do exit. So if I'll type the host name, so currently now I'm in my the bastion host. Okay, so here from here, if I'll try to do ping google.com, so I'm getting the responses. It means my public instance has the internet access using the internet gateway, but my private instance does not have. Okay, so let me stop this, and I'll again uh, connect to my private instance. Let me clear the screen. Okay, now let us go back to our VPC, and here let us check. Let me refresh this. Okay, so you can see now it is in the available state and connectivity type is public. So what we'll do, we'll go to our route tables. Okay, and we'll select the private route table. We'll click on the route, and we'll click on edit routes. So here you need to add a route, and you need to select anywhere, and then if you'll go to the target, you'll get an option for the NAT gateway. Click on the NAT gateway, and it will show the NAT gateway what we have created now. Just select that particular NAT gateway and click on save changes. Okay, so the changes will be applied as soon as you save that, and let us go and verify that in our instance. So let us check we are connected to which one host name. It says 10.0.2.30, and let us check that in the EC2, which is that IP. So you can see this is the private IP for the this app server private instance. I mean the instance we have in the private subnet. Okay, now let us try to ping the google.com again from here, and now you can see like we are getting the response from the google.com, and we are able to access the internet from here. Okay, let me stop it. You can even do curl example.com, and you can get the response. So in this way you can verify. Okay, so yeah, that's all for this video, and if you are doing the hands-on, do not forget to close your instances and delete your elastic IP, or you will be get charged unnecessarily. So if you like our video and it helped you, do like, share, and subscribe it. Thank you.